This is the continuation of our trigonometry video. We are mostly going to be looking at sections 8.3 and 8.4, maybe just a little bit of 8.5, not too much. So you may need to stop it in the middle and continue it on the days that you are working on those. Section 8.3 is mostly just calculator math. All right, we already talked about SOHCAHTOA, and if you'll remember, that gave us our trigonometric functions of sine, cosine, and tangent. They had specific ratios. The sine was equal to the opposite over the hypotenuse. The cosine was adjacent over the hypotenuse, and the tangent was opposite over adjacent. Today we're simply going to apply it to our calculators. If you don't have your calculator with you, you might want to get it and be able to look at it while we're talking about this. All right, you should see buttons that have the abbreviations. Remember, we talked about those: SIN, COS, and TAN. You should be able to find those buttons. All right, so if I know that I have a 30-degree angle, remember these are always right triangles, and if my angle, if I know it to be 30 degrees and I want the sine, now I'm not concerned about what the opposite value and the hypotenuse value is. I simply want a decimal answer. Then I can think about that as the sine of 30 degrees is equal to. I want to find out what that is. We're just going to put it into our calculators. When we do that, ours are indirect entry calculators, so we're going to type in 30 and then we're going to push the sine button, and we should get 0.5 when we do that. So try it and make sure that's what you get. So anytime I know the angle and I want to find the sine, the cosine, or the tangent, that's going to be my strategy. So you'll have an entire section on the top of page, I lost my page, top of page 401, that will just be practice. Make sure that you take note of what the rules are for the rounding and do that correctly. All right, now sometimes, however, I know what the sine is already and I want to find the angle. For instance, looking at this backwards, if I knew that the sine of angle theta was equal to 0.5, then I want to find what angle theta is. In order to do that, I'm going to take the inverse. This is kind of like taking the square root of a square. They cancel each other out and just give us the radicand. So here, if I want the sine of the sine of theta is equal to 0.5, I need to take the arc sine of both sides. Now this is explained in your notes. The arc sine, or the inverse sine, is what we call it. But in your calculator, you get that by pushing the second button and then the sine button. But we do not call it second sine. Don't ever refer to it as second sine. It is arc sine or it is inverse sine. So in this particular case, what's going to happen is, in order to find out what angle has a sine of 0.5, I'm going to take the inverse sine of each one, which will give me theta is equal to the arc sine or the inverse sine of 0.5. Now what this basically boils down to in your calculator is I'm going to put in 0.5 and push the inverse sine button. So 0.5, my number goes in first, and then I'm going to push the second button. Did you come for instruction? Second sine. Okay, so 0.5, push the second button, and then the sine button, and you should get 30 degrees. All right, so test that out and see if it works. Now you'll notice on page 401 in the second section that sometimes, instead of giving a decimal value, they give you a fraction. For instance, number 9 says that the sine of theta is equal to 4/5. Just put 4/5 in your calculator. Either use the fraction button or 4 divided by 5. If you do 4 divided by 5, make sure you push equal and then take the arc sine. So 4/5, use the second button and push the sine. Now I forgot to mention this in the very beginning, but anytime we're using our calculator for trigonometric functions, we need to make sure that it's in degree mode. That's in your notes as well, okay? So you should see up in the upper right-hand corner, it should say DEG. If it doesn't, then go over by the second sign and find the DRG button and push it until you have DEG up in the upper right. It will not give you the right values if you do not have DEG up there. Okay, so take note of that. All right, that should finish up 8.3. Now, 8.4 is an application. There is a very important page on page 403. On page 403, they give you real life scenarios. Like the squirrel is climbing up the tree, okay? If we want to know the tree trunk length, then obviously that's a vertical amount. If he scampers out on a limb, then that's going to be a horizontal amount. And so they give you in table D on page 403 a lot of information that you need to study. And then I've asked you to study all those examples and do the first 8 problems on page 408. Now on page 408, you're simply drawing the pictures. And then I gave you the answers. So check your answers. Make sure you know how to draw those pictures right. Once you know that you're drawing them correctly, then the rest of them will be setting up your own diagram and simply following through with the calculator math to find what the angle is. All right. That should cover that just fine. I think we will just go ahead and tack on 8.5 the radian measure real quickly. Radians are simply a different way to measure, kind of like we use pounds, and overseas they use kilograms, okay, and we can convert between them. So the same thing here, we are used to using degrees, but there is another measure called radians, all right. It's not something I'm going to explain right now. The explanation is in your book if you want to. Basically, you've taken the length of the radius and you've moved it all the way around the circle. So you can read up on that if you want to. But what's important here is to be able to transfer, to convert between the two. All right, there's a formula in your book on page 411. If you already have degrees and you want to find radians, multiply by pi radians divided by 180 degrees. If you want to go the other direction from radians to degrees, multiply by 180 degrees over pi radians. Now, if you are finding degrees, always put your little degree symbol up there. If you're finding radians, they have no units, just put the number. That's why the little degree symbol is so important when we're looking there, because otherwise it implies it's radians. And if you'll notice, in the radians, the pi's are always in there. Don't multiply by 3.14, keep the pi. So follow your examples there, and that should work pretty well. I've already got some explanation written there as well. So hope that works for you. Hope things are still going well, and just continue on with your trigonometry, and I will have more lessons sometime after the next pickup date on Wednesday, I believe. All right, goodbye.